Before we get into the declaration, it's essential to grasp the significance of what is at stake regarding the Large Hadron Collider, LHC, operated by CERN. It marks a monumental achievement in scientific progress. Spanning 17 miles, this sophisticated array of superconducting magnets stands as the largest and most powerful particle accelerator ever created. It serves as a symbol of human creativity and the extraordinary achievements we have made in comprehending science. The LHC is astonishingly capable of recreating the conditions that existed during the very beginning of the universe. However, as we venture into the cosmic unknown, a crucial question arises. Could this machine, which aims to reveal the universe's deepest secrets, also expose us to unforeseen risks? Founded in 1954, CERN is one of the world's most respected scientific institutions, with 23 member nations and a vast community of researchers. It is a place where people collaborate on groundbreaking discoveries. Although the LHC is its flagship project, it's just one of many experiments and particle accelerators. Think of it not as a racetrack for cars or horses, but as one for subatomic particles engaged in a high-stakes race to test the limits of speed, precision, and the very essence of space and time. Inside the LHC, protons are accelerated to speeds nearing the speed of light, mimicking the energy levels present during the Big Bang. The resulting collisions reach temperatures that far exceed the core of the Sun. A system of magnets guides the protons along their paths, while advanced cooling systems maintain the magnets at temperatures colder than outer space. These collisions are deliberately staged at 4 distinct points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, gather data. Each detector has a unique function, providing different perspectives on the aftermath of these high-energy impacts. These detectors work together as immense cameras, capturing the aftermath of these crashes. Scientists meticulously examine the debris to identify elusive particles, such as the Higgs boson, often referred to as the God particle, and other phenomena that might illuminate the fundamental building blocks of the universe. By zooming in on subatomic particles, researchers aim to understand the very structure of the cosmos. Nonetheless, each new discovery at the LHC raises even more questions. The LHC is not just a machine. It represents the unwavering curiosity of humanity and our relentless pursuit of knowledge. It embodies our desire to comprehend the forces that shape our existence. But as we expand the boundaries of the unknown, we must confront the moral and existential challenges that accompany it. What dangers might arise from probing the unknown? Could our search for knowledge unleash powers beyond our control? At CERN, where the limits of human comprehension are being pushed to their utmost, a disturbing realization has emerged, one that has unsettled even Brian Cox, a former CERN researcher and highly regarded figure in particle physics. Cox recently made a chilling statement that has both intrigued and alarmed people worldwide. He explained that the LHC's purpose is to simulate a small-scale version of the Big Bang, essentially a miniature Big Bang. He elaborated on the immense potential of the LHC to uncover groundbreaking discoveries, such as unraveling the mysteries of dark matter, a substance that constitutes much of the universe. The possibility of harnessing the universe's fundamental forces is unquestionably exciting, but it also comes with significant risks. The miniature Big Bang is not just a theoretical concept. It is a real phenomenon that occurs within the LHC. The collider reproduces conditions of extreme heat, pressure, and energy, mirroring the environment at the universe's birth. It's as if we are observing the very beginning of time itself. However, with such vast power comes immense responsibility. What if something goes wrong? This concern is not a new one. In 1978, Anatoly Bugorsky, a Russian physicist, had an experience that forever altered the course of his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a glitch caused a proton beam to unintentionally cross his path. Traveling at unimaginable speeds, the beam pierced his skull, entering from the back and exiting through his nose. those struck by a flash of light more brilliant than 1,000 suns. Bugorski remained conscious and sought medical treatment. The consequences were both astounding and terrifying. He lost hearing in one ear and experienced partial facial paralysis. Despite the severity of his injury, his cognitive functions remained intact, and he continued his scientific work. Bugorski's experience serves as a grim reminder of the power and potential hazards associated with particle accelerators. The dangers of devices like the LHC should never be underestimated. Some scientists have raised concerns about the potential for unexpected outcomes that could alter the very fabric of reality. For example, there are worries that the LHC could potentially create a miniature black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These destructive forces exist at the edges of the universe, and the concept that the LHC might produce even a tiny black hole is both fascinating and frightening. Could such a black hole grow uncontrollably, ultimately consuming the Earth from the inside out? Researchers have attempted to reassure the public, claiming that any black hole formed within the collider would be highly unstable and would disappear almost immediately. Still, the mere possibility of such an occurrence has sparked considerable debate and concern. To understand how the LHC could create a black hole, it is essential to grasp the fundamentals of particle accelerator mechanics. When protons collide at nearly the speed of light, the energy released is so immense that it can distort the very fabric of space and time. To visualize this, imagine a trampoline stretched tightly, with a heavy object dropped onto it. The fabric sways, and if the object is sufficiently large, it can create a depression deep enough to pull anything nearby into it. This illustrates how the LHC might affect space-time at a quantum level, where the laws of physics become unpredictable. One theory suggests that extra dimensions, beyond the familiar 3 dimensions of space and 1 of time, might exist. If such extra dimensions exist, the LHC might have the capacity to access them, potentially forming a gravitational well that leads to a tiny black hole. This possibility has intrigued renowned physicists, including the late Stephen Hawking. In his writings, Hawking cautioned that the Higgs boson might become unstable at extreme energy levels, possibly triggering catastrophic events such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised alarms about the LHC's experiments. In his book On Humanity's Future, Rees acknowledged that while the chances of such an event are low, even a small probability warrants serious consideration. The stakes are extremely high, and the margin for error is razor-thin. CERN researchers have conducted numerous simulations and analyses, taking every measure to ensure the safety of their experiments. Brian Cox himself has addressed the issues surrounding the LHC, emphasizing that stringent safety protocols are in place. If the Large Hadron Collider, LHC, were to access these hidden dimensions, the implications would be profound. Physicists speculate that it could provide evidence supporting string theory and unlock a deeper understanding of the universe's structure. However, this prospect also raises unsettling questions. Could tampering with extra dimensions lead to consequences beyond our control? Might we inadvertently trigger phenomena that defy current scientific knowledge? The idea of parallel universes intersecting with our own is both exhilarating and terrifying. Theoretical physicist Michio Kaku has discussed the possibility that advanced technology could one day allow us to travel between dimensions. Yet, if the LHC were to create a temporary portal or gateway, even unintentionally, it could have unpredictable effects on our reality. While mainstream scientists regard such scenarios as improbable, they cannot be entirely dismissed. Moreover, the concept of vacuum decay presents another theoretical danger. In simple terms, our universe exists in a stable vacuum state. However, at extreme energy levels, such as those within the LHC, there's a remote possibility that the vacuum could transition to a lower energy state. This process, known as false vacuum decay, could theoretically spread at the speed of light, annihilating everything in its path. Although the likelihood of this event is astronomically low, its potential consequences are catastrophic, making it a subject of both scientific scrutiny and public concern. Despite these concerns, CERN maintains that the LHC is safe. Extensive studies, including reports from the CERN Safety Assessment Group, conclude that the energy levels produced in the collider are comparable to natural cosmic ray collisions that have occurred for billions of years without adverse effects. Additionally, any black holes formed would be microscopic, evaporating almost instantly due to Hawking radiation. The scientific consensus is that the LHC poses no significant threat to Earth or the universe. Still, the public's imagination continues to be captivated by the unknown. Some speculate that the LHC's experiments could lead to phenomena beyond conventional physics, time distortions, anomalies in space-time, or even contact with extraterrestrial intelligence. While such ideas belong more to science fiction than science, they highlight humanity's fascination with the boundaries of knowledge and the risks of pushing those boundaries too far. In this pursuit of discovery, ethical considerations must not be overlooked. Scientists have a moral responsibility to weigh the potential risks and benefits of their research. The desire to unlock the universe's secrets should never come at the expense of humanity's safety. Transparent communication with the public is essential to build trust and ensure that groundbreaking experiments are conducted responsibly. As we stand on the precipice of scientific discovery, the LHC symbolizes both our greatest aspirations and our deepest fears. It is a testament to human ingenuity, yet a reminder of our limitations. The questions it seeks to answer: what is the universe made of? How did it begin? Are we alone? Lie at the core of our existence. While the journey toward these answers is fraught with uncertainty, it is a journey that defines us as a species. Ultimately, the Large Hadron Collider represents a paradox, a machine capable of unlocking the universe's greatest mysteries while posing questions about the limits of scientific exploration. As we peer into the unknown, we must proceed with both courage and caution, mindful that the pursuit of knowledge, though noble, carries responsibilities as profound as the discoveries themselves. Conditions that they might hypothetically be accessed. Think of the LHC as a key unlocking doors to realms that have remained hidden since the beginning of time. When protons collide with energies never before seen on Earth, they might create ripples that peer into these buried dimensions. For the time being, this is speculative, but it shows the allure of the unknown. The possibility of discovering other dimensions continues to captivate, despite the fact that most scientists remain skeptical that the LHC will open a portal to another universe, or to something far more terrifying. Should we be concerned about the risks associated with the LHC? It's easy to get caught up in hypnotic headlines and worries about catastrophes in the universe. However, the truth is that CERN scientists are fully aware of the potential risks and have taken extensive precautions to ensure the safety of their experiments. They constantly monitor and evaluate their work, performing tasks with the utmost diligence. The potential benefits of their research, such as deciphering the mysteries of dark matter, discovering new particles, and deepening our understanding of the universe, are truly remarkable. These breakthroughs represent an important leap forward in human knowledge. Yet, as with all groundbreaking scientific advances, inherent dangers exist. Present results from LHC experiments raise profound ethical dilemmas. The creation of exotic particles or the investigation of extreme energy conditions could result in unanticipated consequences for our planet or even for the very fabric of reality itself. These inquiries cannot be ignored and must be carefully considered within the broader context of scientific progress. The Large Hadron Collider is a monumental achievement of human curiosity and ingenuity. It has already led to groundbreaking discoveries in particle physics, providing insights into the fundamental aspects of how the universe operates. As we investigate these unknown territories, we must remain vigilant and aware of the potential risks involved. One of humanity's most ambitious pursuits is the search for knowledge, but it is not without challenges. The LHC stands at the forefront of scientific experimentation, where theory meets practice and the fundamentals of our understanding of the universe are put to the test. Peril and danger are always present in discovery, and the LHC is no exception. It tests the limits of physics, seeking to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical dilemmas that arise from manipulating the forces that govern the universe. The risks of unintended consequences, whether for our planet or the fabric of space-time itself, remain an obstacle that demands thoughtful reflection. Nonetheless, the pursuit of knowledge is still one of humanity's most noble endeavors. Although risky, the LHC's experiments offer us glimpses into vast, undiscovered realms of science. As we approach the point of discovery, we must proceed with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement, but also a powerful tool capable of reshaping our perception of everything, from the smallest subatomic particles to the most astonishing events in space and time. With each breakthrough, brand new questions emerge, opening up new possibilities for research and thought. The path of scientific discovery is uncertain, but it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's experiments is the intersection of theory and reality. For decades, physicists have grappled with understanding the forces that control gravity, the weak nuclear force, electromagnetism, and the strong nuclear force. The ultimate goal has always been to unify these forces into a comprehensive framework, a theory of everything. The LHC has played a pivotal role in providing insights and experimental evidence that bring us closer to this elusive objective. Its work not only enhances our understanding of specific physics phenomena, but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are considerable. Risks have always accompanied the pursuit of knowledge, but when those dangers involve altering the fabric of time and space, the stakes increase exponentially. Could a single LHC experiment inadvertently trigger an event we don't fully understand, leading to consequences beyond our ability to predict? Scientists, philosophers, and ethicists continue to investigate this question as we explore these uncharted realms. We must remember the responsibilities that come with wielding such vast power. Yet, few would argue against the immense benefits of scientific advancement. Emerging technologies, medical breakthroughs, and a deeper understanding of the universe owe much to discoveries made by the LHC. Its identification of the Higgs boson and advancements in our knowledge of dark matter have already transformed the scientific landscape. These achievements have far-reaching implications, not only for physics, but also for other fields that rely on this foundational knowledge. As we continue pushing the boundaries of possibility, the LHC stands as a reminder that science is never without uncertainty. No experiment is risk-free, and as grand and powerful as the LHC is, it is no exception. Yet, with every risk comes the potential for monumental discoveries. The LHC symbolizes humanity's relentless search for information, a quest to answer the questions that have puzzled us for centuries. Ultimately, it is this thirst for knowledge that propels us forward, a desire to comprehend the cosmos, explore the depths of time and space, and uncover the forces that govern everything, from the smallest atoms to the largest galaxies. The LHC may carry risks, but it also represents the zenith of human progress in particle physics. It is a tool that enables us to explore the most profound questions about existence, challenging the fundamental rules of nature and attempting to solve the mysteries that have eluded us for millennia. Whether the LHC leads to the discovery of new dimensions, opens portals to parallel universes, or triggers unexpected events remains unknown. However, one thing is certain. It is one of the most powerful instruments ever created, capable of unlocking universe-wide secrets that were once thought to be beyond our reach. The potential for discovery is boundless. As we journey further into the unknown, we are reminded that science is a voyage, one that requires both courage and responsibility. The experiments at CERN continue, and we must remain vigilant to the possibilities, dangers, and immense potential for new understanding that lies ahead. The LHC, while embodying the cutting edge of modern science, also reflects our deeper quest for meaning and understanding in a vast and mysterious universe. Each new discovery brings us one step closer to a more complete comprehension of the forces that shape our existence.